Welcome to the exciting world of Java programming. In this journey, we'll explore a fundamental concept that underpins how Java works. Object-oriented programming, often shortened to OOP. Think of it as a way of organizing your code, making it more efficient and easier to manage. At the heart of OOP lie objects, just like in the real world, where we encounter objects like cars, houses, and even ourselves in programming. Objects help us represent and manipulate data in a structured way. Imagine building a virtual house in your code. You wouldn't want to write thousands of lines of code just to define every single detail, would you? That's where OOP comes in. It allows us to create reusable blueprints called classes, which define the properties and behaviors of objects. So buckle up as we dive into the core concepts of OOP in Java, starting with the fundamental building blocks, classes, and objects. Let's imagine we're architects for a moment. Before we can build a house, we need a blueprint. In Java, that blueprint is called a class. A class is like a template that defines what an object of that type will look like and how it will behave. For example, our house blueprint might specify the number of rooms, the color of the walls, and whether it has a garage. Now, when we actually want to build a house, we create an object based on that blueprint. Each house we build from the blueprint is an object, an instance of the class house. Let's see how this translates into Java code. Public class house. In this code, we define a class called house. It has properties like numRooms, wall color, and has garage. The constructor lets us create new objects with specific characteristics. In the previous section, we briefly touched upon constructors. Now, let's delve a little deeper into these special methods that play a crucial role in creating objects from classes. Constructors are like the construction crew that uses our blueprint to build the actual house. They initialize the object's properties when it's created. Think of it like this. When a new house is built, the construction crew uses the blueprint to determine the number of rooms, paint the walls the right color, and add a garage if needed. Constructors do the same thing in Java. Public class car. In this example, we have a class. The default constructor sets default values for color and year. The parameterized constructor lets us specify the color and year when creating an object. One of the most powerful features of OOP is inheritance. Imagine you're building different types of houses, a bungalow, a duplex, and a mansion. They all share some common features like walls, doors, and a roof. Instead of defining these features repeatedly for each house type, wouldn't it be great to reuse the code? That's where inheritance comes in. It allows us to create new classes, child classes, that inherit properties and behaviors from existing classes, parent classes. Think of the parent class as a general blueprint, and the child classes as more specialized versions. The child class automatically gets everything from the parent class and can add its own unique features. Class animal / parent class public void eat. System out println animal is eating. Class dog extends animal / dog inherits from animal public void bark. System out println dog is barking. In this code is the parent class, is the child class inheriting from. An object can use both from and its own method. Section 5 Method Overriding Customizing Inherited Behavior. We've seen how inheritance lets child classes inherit methods from parent classes, but what if a child class wants to perform a particular action differently than its parent? That's where method overriding comes into play. Method overriding allows a child class to provide its own implementation for a method that's already defined in its parent class. It's like saying, I want to inherit this method, but I want it to work a little differently for my specific class. Think of a car and a bicycle, both inheriting from the vehicle class. The accelerate method might work differently for each. A car accelerates by using an engine, while a bicycle accelerates through pedaling. Class animal, public void make sound. System out println, animal makes a sound. Class cat extends animal at override public void make sound. System out println, meow. In this example, both and have a method. The class overrides the method to produce a meow sound. Section 6. Polymorphism, the power of many forms. Polymorphism, a big word that simply means many forms, is a core concept in OOP. It allows objects of different classes to be treated as objects of a common type. It's like having a single remote control that can control different devices, each responding to the same commands in its own way. There are two main ways we achieve polymorphism in Java. 1. Method overloading, defining multiple methods in the same class with the same name but different parameters, whether different data types or a different number of parameters. 2. Method overriding, which we just explored, where a child class provides a specific implementation for a method that's already defined in its parent class. For example, consider the following Java code: Java class, shape, public void draw, system out.println drawing a shape, class circle extends shape at override public void draw, system out.println drawing a circle, class square extends shape at override public void draw, system out.println drawing a square. In this example, we have and classes. Each class has its own method, demonstrating polymorphism. Section 7. Encapsulation, shielding data, ensuring integrity. Encapsulation is like building a protective capsule around the data and methods within a class. It's a way to control access to the internal workings of an object and prevent accidental or unauthorized modifications. Think of a bank account. You can deposit and withdraw money, but you can't directly access the bank's vault or change the interest rates. Encapsulation ensures that data is accessed and modified in a controlled manner through well-defined methods. We achieve encapsulation in Java by declaring variables as, making them accessible only within the class, and providing public and methods to access and modify the private variables. For instance, consider this Java code: Java public class bank account, private double balance, public double get balance, return balance, public void deposit, double amount, balance plus equal sign amount. In this code is private. It can only be accessed or modified using the and methods. Section 8. Abstraction. Simplifying complexity, focusing on essentials. Abstraction is all about simplifying things by hiding unnecessary details and presenting only the essential information to the user. Think of a car's steering wheel. You turn the wheel to steer, but you don't need to know the complex mechanics of how turning the wheel actually turns the car's wheels. In Java, we achieve abstraction using abstract classes and interfaces. Abstract classes provide a blueprint for other classes but cannot be instantiated themselves. They often have abstract methods which are like placeholders that must be implemented by the concrete child classes. Interfaces define a contract that implementing classes must adhere to, specifying methods that the classes must implement. Here's an example. Java abstract class animal / abstract class dog extends animal. In this example is abstract. You can't create an object directly. A concrete class must implement the method. Section 9. Conclusion. OOP. A powerful paradigm for Java development. Congratulations on making it to the end of our OOP adventure. We've explored the fundamental concepts that form the backbone of object-oriented programming in Java: classes, objects, constructors, inheritance, polymorphism, encapsulation, and abstraction. By embracing OOP principles, you'll write more organized, reusable, and maintainable code. Keep in mind that mastering OOP takes time and practice. As you continue your Java journey, you'll discover even more ways to leverage these concepts to build robust and scalable applications. So, keep experimenting, keep learning, and keep building amazing things with Java.